going to take a look at the R programming language. The R language is used mainly for statistics and graphics. It is very popular in the data analysis field, used by data miners, bioinformaticians, and statisticians. I like to compare it to Python since both languages are popular among data scientists and data analysts, and they both have an easy syntax. The big difference between R and Python and all of the languages I used so far is that it was developed specifically for statistical analysis. It is not a general purpose language. So how is it possible to make a game with this language? Luckily, thanks to a package called Rcpp, calling C or C++ code from R is quite easy. This package allows you to, as it says here, extend and grow R applications by using a performance C++ interface. This package is used by another one called Rcpp. Rcpp is the C library that I use in my past videos to make games. This package is developed by Jeroen Janssens. He made a great talk about it in a conference in New York. With this package, you can call all of Rcpp functions from R. The main idea of this package is to take advantage of Rcpp to make interactive 2D or 3D plots, but it can also be used to make games. So I made one. The game is pretty simple, a top-down tennis game mixed with Minesweeper. We can split the game into 4 parts: the player, the ball machine, the ball itself and its physics, and the Minesweeper grid. Let's take a look. So here's the main script. Here I'm using 2 libraries, Rcpp, obviously, and enumerations. This library allows me to create enumerators. For example, in the animation script, I create an enumerator that contains the different animations of the play. So if I want to set a variable to none, I simply write animation ID $none. So this is how you index a value which is inside an object or a list or an enumerator. So here I initialize the game, which is inside the game script. I initialize the window, set the FPS, initialize the audio device, and here I create the game object, which is a list containing all of these objects, which are also lists, and here I return the game object. So here's one thing I found quite strange about this language, but it's a thing that reminds me of functional programming languages, is that to return a variable, you can just write the variable, and the last expression detected by this function is the one returned. But you can also explicitly write the return keyword, but return in this language is not a keyword. It is actually a function, so you have to wrap this variable with parentheses. It is something I found quite strange, but as I said, it reminds me of functional languages where you don't have a return keyword. You just simply write the expression. But I prefer to explicitly write the return. So here, here's the main game loop. Here I check for the game over timer, because when the player hits a mine, I don't want to immediately jump to the game over screen, but I want to wait for a little while. The reset, where I simply reset all of the different objects when the player hits the R key. The update game, which update all of the different objects. Here's something again that I found quite strange about this language, but it also reminds me of functional programming language, is that there is no way to pass a variable by reference. So if I should simply call update game and pass the game object, all of the changes I do to this variable will not be reflected in the game object. So that's why I have to pass this parameter, and then at the end of the function, I have to return it. So here in the main script, I have to set it to the game variable. So all of the changes are saved. It is something I found quite annoying because there are some functions where I have to return two objects, and this language you can return more than one variable. So what I have to do is return a list containing the two objects, and here I have to get that list and then update the two objects. But again, as I said, this reminds me a lot of functional programming languages, and well, I can use this workaround around that because I don't really like functional programming languages. It is not really my thing, but anyway, here's the drawing part. I simply call the draw game function if the game is not over. Otherwise, I print this to the screen. So here in the game script, well, the source function is a way to include all of these different scripts. So here in the update game function, well, I update the music, check if the player wants to show the FPS on the screen. Here I update the player, and this is how I update the player object and the ball object. As I mentioned before, I have to return a list with these two objects. Update the ball pointer, which is the red circle, which shows where the player is aiming. Here I set the flag, which is in Minesweeper. The player can set a flag where the player believes there's a mine. Here I set the victory screen. Here I update the ball if the ball speed is different than 0. So if the ball is moving from the ball machine to the player, the ball speed is positive because the y value is increasing. If it is the other way around, the y value of the ball is decreasing, so the speed is negative. Here I set the game over screen, and here I update the ball machine, which also has different states, which is enumerator, shoot, which simply shoots a ball, wait for the ball to leave the screen, and wait for a time. And well, here I draw all of the different objects and this text when the player wins the game. So here in the player script, I set the different animations. I have to set the animation object, the animation enumerator, the size of the texture, and the size of one frame, and the different delays of each individual frame. Well, here's the player movement, the 8-directional movement. I simply check for the key press and set the dx and dy variables. If the dx and dy variable different than 0, I normalize it and set the moving animation. If the player is not moving, then dx and dy are 0, and so I set the idle animation. And here I update the position of the player if the player is not off limits. So in the update player function, first I check if I update the animation, and then I check if the player is not hitting the ball, which means if not playing any of these animations. In that case, I set the can move to true. And here I check if the player wants to hit the ball with the spacebar key. I check if the movement points of the ball is bigger than 1. The movement points are simply the points which the ball will follow to move. And check if the state is none, because the player, when hitting the ball, also had different states. None is when the player is not hitting the ball, and then you have another state where the player is waiting for the ball to get close, and then you had a state when the player is hitting the ball. And here I check if the Y position of the ball is less than the player position. If that's the case, then I have to check if any of these movement points is inside the player rectangle. So here I check with this Rayleigh function, the collision between a point and a rectangle. If it collides, then I lock the player's movement. And here I check the distance between the player position and the ball and the angle where the player is going to hit the ball. So depending on these two variables, I set the different animations. If the ball is too close to the player and the C position of the ball is bigger than this number, then I set the high ball animation. If the angle is less than 90 degrees, I set the hit animation, and otherwise I set the reverse animation. Here I pause the animation because the player has to wait for the ball, which means the ball needs to be close to the player in order to hit it. So what I do is set the first frame of the animation and then wait for the ball. So if the player is waiting for the ball to get close to, to him, then I check for the collision between the current position of the ball and the player position. If these two rectangles collide, then I play the player's animation. I reset the movement points of the ball, play the hitting sound, and well, I call the shoot ball 2, which shoots the ball to a specific position, which in this case is the position of the ball pointer. Here is one thing I had to do because sometimes the player is in the wait ball state. In this state, the player can move. So here I wait for the ball to get close to the player, but there are some rare cases where the ball does not get too close to the player. So the player gets stuck in this state. So here I check if this is the case and the ball is off screen. I simply set that the player can move, reset the state of the ball state of the player, and set the pause variable to false. And here, well, if the player can move, I update the player movement. And here, as I mentioned before, is one way to return different variables. I create a list with the player and the ball. Well, and here's the draw player, which simply draws the animation, reset player, and unload. Well, finally, let's take a look at the ball script, which is probably the longest and most complex script of all of these. So here you can see there's a lot of different variables inside the ball object. So the most interesting thing about this script is the way I move the ball. So basically, the movement of the ball is that of a parabola. So let me show you with an example. So basically, I want a function which increases the C value of the ball. The C position is actually the scale of the ball. So if the scale of the ball increases, then the ball gets bigger, and if it decreases, then the ball gets small. So basically, what I need is the function of a parabola. So everyone knows that the most common parabola is x squared. But the thing is, I want this parabola to be upside down because I want to increase and then decrease. So what I have to do is set this x value negative. And now I need this parabola to start from 1 and then start moving from there. So what I have to do is add 1 to this parabola. And now what I have to do is move this point of the parabola from here, because with this parabola the ball will start decreasing. So I simply have to add x to this function, and this parabola is very small, so what I do is set 2x. So now this is the parabola I use for the movement of the ball. But now I want to change this parabola depending if the ball has to move far away or not so far away. So what I do is set one parameter of this parabola, which is this minus x squared. So here I set one variable which I can modify however I like. So here you can see, changing the value of a, I can make this parabola bigger or smaller. So basically what I do is set a specific value of this variable, and I have the different parabolas. I have to set the maximum value and the minimum value for all of these different parabolas. So going back to the script, here you can see in the update val function, here I simply, first I have to move the x and y variables, and here I update the c position, which is actually, as I mentioned before, the scale of the ball with the parabola function that I mentioned in the plot. So here we have I, which is the x value, increases in steps of 0.01. So here I have I squared times the force, which is actually the variable I set to get a different parabola, plus 2 times I plus 1. So this is the equation of the parabola that I showed before. So here I have to check when the C position is less than 1, because here is where the ball is bouncing. So here in the parabola, it starts going from 1, which is the scale of the ball is 1, it increases, and then it gets to 1 again. So I have to check when this value is 1. So here I check if the C position of the ball is less than 1, it means that the ball is bouncing. So here I check if the ball bounces for the first time, then I get the X and Y position of the tile by subtracting the X and Y position of the ball minus the offset X and Y values of the field, divided by 32, which is the size of the tile. This is how you do integer division in our language. So here I check if the mines are set. If the mines are not set, I want to initialize the grid. I do this because I don't want the player to step on a mine on the first try. So here I check if the ball is in bounds of the Minesweeper grid, and I check if the player wants to set a flag, because in Minesweeper you can set a flag in the tiles the player believes there is a mine. So here I simply update the value of this boolean, or if the player doesn't want to place a flag, but the tile where the player hit the ball is a mine, and that mine doesn't have a flag, then it's game over. Here I reveal all of the tiles that had mines. Otherwise, if it doesn't have a flag and it is not a mine, then I simply call for the check cell function, which is basically is the algorithm of the Minesweeper. So you can see here, check the check cell function, simply reveal this particular tile. If the number of that tile is 0, it means that this tile doesn't have any adjacent mines on it. Then I simply get all of the neighbor tiles and recursively call the same function for each of those tiles. Otherwise, I check for if the player won by simply iterating over all of the tiles and checking if all of the tiles with numbers bigger than 0 were revealed. Well, here I play the sound of the ball bouncing. I set the bounce once flag to true and shoot ball, which set the force of the ball and the direction and all of the variables. Here you can see that I'm passing to this function ball force times 2. This is because I want when this parameter gets bigger, the parabola is smaller, so the parabola of the ball gets smaller. The name of the variable is kind of misleading because it's not really a force but a parameter of the parabola. So here I check if it is not the first time the ball bounces, so I simply play the sound, shoot the ball, and set this variable to true. Here I check if the ball is off screen, then I simply set the default parameters of the ball. I reset the movement points array and set the speed to 0. So the update function of the ball won't be called. Here's the most interesting part of this code. In the draw ball, I not only draw the ball, but I also draw a yellow circle where it indicates where the ball is going to bounce. So here, if the ball speed is different than 0, then I have to check where the ball is going to bounce. So I have to check the position, this position of the parabola. So here in the notes folder, so simply all we have to do is we have to check in this equation when it is equal to 1. We already know from this graphic here, we can see that one position that the parabola is 1 is at 0, but we want to get this position. So simply we have to simplify this equation by simply setting it equal to 1, and we have to get the x position depending of the force. So as you can see here, the parabola at 1 is 2 divided by the force. So this is the parabola when c is equal to 1. And also we need to get the number of iterations, because remember this x value in the code is actually called I here. So this take a number of steps which increases by 0.01. So here, so the number of iterations is simply this value divided by 0.01. We get the saving of this value plus 1. So here we get the ending of this parabola. You get the step count. So here, this value, which is the movement of the ball in the x and y position, are constant values because the speed and the angle doesn't change. So to get the position of where the ball is going to bounce, the x and y position, I simply have to add the origin of the where the ball started the position plus this value, which as I said doesn't change, the speed times cosinus or sinus of the angle times the step count, which is this number that I calculated here. And with these two values, I can draw a circle in the position where the ball is going to bounce. It's simple as that. Maybe I overcomplicated it a little, but it's actually very simple. And well, that's pretty much it about the game. I still have to talk about a couple of the script, but I think that's pretty much the most important part of the game. So here, as I mentioned before, this is the basic algorithm of any Minesweeper game, simply by checking which cell we want to reveal, and that's pretty much it. So yeah, thank you very much for watching.